Hello, in this video we will analyze a new structure, in this case a Warren Bridge, common in pedestrian bridges. We will show step by step the generation of the 3D model until we reach the analysis of the reinforcement. This is a common type of truss for bridges. We show in the picture some other common types of bridges. We start in the software a new part from the home screen. We create a new sketch in 2 dimensions, selecting the XY plane. We start with a line of 3 meters from the origin and on the y-axis. I project this 3-meter line to the right a distance of 1.5 meters, 4 times with the offset tool. To draw the inclined lines, I take the parallel lines as reference, as shown in the geometry. Eliminate the vertical lines, leaving only the outline of the inclined lines. I will leave the initial line to use it as a stroke line. Using the initial line of the stroke, I use the mirror tool, selecting the lines that I want to copy and the mirror line. Now I build a horizontal line, on top of the geometry. Also a full line at the bottom. I finish the sketch. In the construction tree, I visualize the XY plane in which I built the geometry. A parallel plane is projected 2 meters away from the original XY plane. A new sketch is generated on this new parallel plane. With the Project Geometry tool, the initial trace is projected to the new plane. Starting from a 3D sketch, I close the upper intersections with lines and later the lower ones, from the projected plane at 2 meters and up to the original plane. I finish the 3D sketch. Now the geometry is ready to insert the commercial profiles. For this we save it on our computer. On the home screen we start a new assembly. Open the previously saved wireframe model. In the Design tab we select Insert Frame. The program asks us to save the assembly to be able to insert the profiles. We select the square profile in the general category and in the ISO standard. I can select all the lines with a window. We need to verify that in all the lines the profile has been inserted and confirm that it is inserted. Now we have the truss for the Warren Bridge ready to define the supports and the loads. From a new structural analysis I create a new simulation, starting from a static analysis. In this initial static analysis I can visualize the nodes that make up the reinforcement. Now I will define the types of support, in this case on one side fixed supports. In the other section of the bridge I will define sliding supports or floating supports. Now it is time to define the charges. In this case I will consider point charges of 5,000 newtons in each of the central elements in the position shown. The vector shown at the center is the vector representing the acceleration due to gravity. Now the assembly is ready to represent the simulation, with profiles, supports and loads. The first result shown is the displacement, which in this case has a value of 12.58 mm. The theoretical deformation can be better observed in an animated simulation. We can observe the value of the normal effort, remembering that it should not be greater than 360 megapascals. We can also observe the results of each beam with its corresponding diagrams. Thanks for watching this tutorial. I hope it has served as a structural reference.